if statements direct the flow of the program. So if I have an if statement and then a condition, it will only execute the code that's in that if statement if that condition happens to be true. Now we also have something called an else. So you have an if condition and then else. So this is going to be the part that executes if it's true, and this is going to be the part that executes if it's false. We also have an else if that we can put in there to have additional conditions. So if you can select between like 3 or more conditions. So let's go through this. I'm just going to have a couple exercises here just to show it. Based on the number of days that an egg has been in an incubator. So if the days is less than 21, I'm going to display those days. If the chick is still developing. So let's go ahead and run this. How long has it been in the incubator? And I'll put 8. Alright, but if I put in something more, then it's not going to run that display code. So I'll say 22, and it's not going to display that message. Let's go ahead and put in an else statement now. If the days is greater than 21, else the chick is still developing. Alright, I'll test it with 22. Run it one more time. Alright, so I got the 2 different messages. Let's go ahead and do our own if statement now. So I'm going to have just a program that's going to run. I'm going to say I'm going to guess 8, and then let's just generate a random number while number is not equal to guess. Then I'm going to regenerate a random integer between 0 and 10. Alright, and I will print that, and then let's go ahead and if x is less than guess, then let's see, I'll say I don't really want to call this guess, I'll call it my number. Okay, and the computers is going to be the guess. Okay, so if guess is less than number, then I'm going to display too low, else display too high, and end. Alright, so let's go ahead and just run this. Alright, and let's see, I have an invalid call to a script. Oh, I have a guess script there. I've got to delete that. Let me go ahead and just delete that script. I don't need that one anymore. Alright. And I think I need to restart the kernel because it already loaded that function in. Okay, so guess is undefined. So I'll just put guess equals 0 initially. Alright, so it guessed until it got it right. Guessed an 8. We didn't want the too high there, so let's go ahead and put one other statement in here. If guess is not equal to number, then we'll print too high. Otherwise it got it right, and we don't want to print too high at the very end. Okay, so we got guess is 8, and then it finished. So we're having the computer do a random number guessing game, and that's how many times it took to get it right. Although the computer is not doing it smart where it's guessing if it's too low, it's just generating a random number there. Alright, so let's go ahead and go on to the next one. Oh, that took a long time to get 8. Alright, so else if, here's another one, enter days. Alright, so we could have else if, okay, should hatch soon, and then else, the chick is still developing. Alright, so let's go ahead and enter in 5. You can see it enters that part of the code, the chick is still developing, and if it's going to be something like 19, then it should hatch soon. Alright, and then let's go ahead and do 22, just do the final one. Alright, so for these logical conditions, you can do an and, a not, an or. If you have multiple things, it would make it true or false. Okay, so there are some of the functions that you can use for comparative statements. All right, so we could do ands there. Should hatch soon. Okay, probably won't hatch if it's above 25. Okay, so you can see it navigating here, but the main thing I wanted to show is that you can do nested if statements, or you can do these comparative statements that help you combine different conditions. All right, so if you put in something like 8, still developing. Okay, so it goes to different sections of the code. Let's go on to the activity. We're going to use an if and else if statement to create a calculator using basic operators. I'll have the user input 2 values to be operated on. So let's go ahead and just do that right now. Input x, and we'll input y. All right, and then we want to have the option of doing addition, subtraction, multiplication, or division. Okay, so we'll do a type, and I'll just put in, copy this, with some instruction. 1 is going to be addition, 2 subtraction, 3 multiplication, and 4 is going to be division. Okay, so we're going to have the user input a number based on what they want. And then we're going to have it do something different. If t equals 1, then that is going to be z equals x plus y. Else if and t equals 2, then we can do z equals x minus y, and another else if 3, and then z equals, and then this is going to be multiplication, and else if one more, t equals 4, or I could just do an else if I wanted to have it catch all the other ones. You wouldn't necessarily want to do that because if it entered a 5, it would do division by default. But let's just go ahead and run it and do 1, 2, and then a 2. Okay, so there's our result. Okay, the next one is we want to use an if statement in a while loop. Create code that turns on the LED when the temperature goes above 30 degrees and disconnects the kit and turns off the LED when the temperature goes above 35. Output the temperature every time the program loops. Set the heater power with a value from input. Okay, so here we go. We're going to go ahead and just clear lab and connect to the TC lab. That's the very first thing. And then we'll say that Q equals input, what heater level. All right, and that's going to be between 0 and 100. And then we're going to have a while loop. While a dot t1 is less than 30, we're going to, let's see, turn off. Okay, so let's just go ahead and do that. Continue until it's above 35. All right, and then we'll have an if statement inside here. So if a dot t1 is greater than 30, then it's going to turn on the LED. Oh, that should be lab, and that should be lab. Lab dot LED, I'll turn it on to 100, else lab dot LED, turn it to 0. All right, and then at the very end, I want to turn it off, and I can also clear the lab. All right, so I have a while loop, I have this if statement, and then I'm going to run it. Now, this could take a little while if you put a low heater value. So I'm just going to do 100 for now, and see if it'll heat up pretty quickly. It has to get up to 35 in order to be able to shut off. So it's at room temperature right now, and it's got to rise about 10 degrees. It might take about a minute to do that, maybe less, but we'll see. All right, so it's going to keep looping, and the one thing I forgot to do here is print out the temperature each time. So I should have done that right here. I'll do that after it finishes running. Okay, I'll go ahead and display, and we'll do lab.t1. Okay, I can go ahead and interrupt the kernel if I want to have it stop. Okay, warning, cannot interrupt Octave on Windows. All right, maybe you can do that on Linux, I'm not sure. But normally we do the restart kernel or interrupt kernel, and it'll stop it and then let you continue. But it looks like Octave on Windows, it doesn't let you do that. Okay, so we're just going to let it run. Actually, I think it did stop now. All right, so what heater level? I got the message that it couldn't connect, so I'm going to have to just reset the Arduino. You can do that with a little button on the Arduino, or you can disconnect it and reconnect the USB connection. So if you get that error, just go ahead and do that. I'm going to restart the kernel just one more time. Okay, and here it goes again. I'm going to run it one more time with it reconnected. All right, I'll do 100. Now it'll display all of these temperature values after it's done. It's going to put a lot of temperature values in here because I didn't put any pause in there for checking it. Okay, so I probably need to do that as well. Maybe pause 1 second so it doesn't have like 50,000 different data points that spit out in the end. Okay, so you might want to put that in your code as well. Let me just restart the kernel one more time so I don't make it output about 50,000 lines of code. And I'm just going to unplug and replug in the Arduino one more time. All right. Let's try it one more time. Heater level 100, and away it goes. Okay, so has to get up to at least 35. It'll just pause every 1 second and then check the temperature again and then turn on the LED. I can watch it to just see when the LED is going to turn on. So I'll tell you when it does turn on from my side, but you'll be able to see that with your device too when you run it. Okay, so we're just going to let this thing go. I'm going to go down to this next one just while we're waiting for the other one to execute. We'll make a guessing game that makes a random LED %, and the user has to type inputs to guess it. Make the program say higher or lower depending on the guess. When the guess is correct, flash the LED for a few seconds and disconnect. So we can use while loops, for loops, if and else statements, input and display, or any combination to create the program. Okay, and what I'm also realizing just now about this is I never set the heater value. All right, so lab.q1 is equal to q. So the heater was off, and that's why it wasn't heating up that whole time. So I'm just going to save this. It should work at this point, but go ahead and try it on yours. Hopefully you'll get it working. This one I know I'm going to have to do like in a Matlab or Octave terminal. So let's go over to Matlab terminal for this one and just make our number guessing game, because I can't do multiple inputs for each loop within the Jupyter Notebook terminal. Okay, I'm going to go ahead and create a new script, and go ahead and just make this just a little bit bigger. so I can see all of it. Okay, so I'm going to just go and clear all when I start, and lab equals TC lab. And then what I want to do is have a guess. I'll just set that to 0 initially, and then while, and then number is not equal to guess. Okay, then I'm going to end, and I'm going to have this set. My number is from a random integer between 0 and 100. Okay, and then I'm going to use the if statements like I did before. So if my guess is less than number, all right, then I'm going to display too low. And then I'm going to do else if, and guess is greater than number, then I'll display too high, and then else I'll display correct. All right. And then I need to update the guess up above. Guess equals input, and I'll just put a question mark there. All right, and it's going to then finish after we're done. I'm going to turn on the LED to that guess number, so you can look at the brightness of it, and then maybe also get a clue about what the number is based on the brightness of the LED. But I'm not going to print out the number, so you might be able to see it in the variable workspace here. Just don't look at it, okay, when you're running. And let's go ahead and do clear lab at the end. All right, let's go ahead and save it. And this is called guessing game. And I'm going to go ahead and run it. And let's just see what it says. I need to connect. I need to connect to the load the drivers for Matlab. So I'm just going to do lab equals Arduino and go ahead and connect to it. All right, I'm going to just unplug and replug it in because it was it says Leonardo detected, and then I'm going to do Arduino just to be able to load the drivers for Matlab. So I was using Octave before. Matlab will go in and just load the drivers so I can use it in Matlab instead. Okay, this takes just a little bit of time. It says updating the server code on the Leonardo. It'll just take, it says a few minutes. Sometimes it takes a few minutes, sometimes it takes just a few seconds. Kind of depends on how fast it's feeling on going at the time. All right, and so this is our number guessing game. All right, looks like it is almost ready to go. Okay, it is ready. Okay, let's go and just clear that and try it one more time. All right, guessing game. Oh, I should have not told the number. I should have put a semicolon here. Okay, I'm going to run it one more time because it just told me the answer. Okay, don't look over here in the workspace area. Maybe I can make that smaller. Okay, so here we have a guess right here, guessing game. Okay, I'm going to do 40. Says too low. 56, too high. 55 was correct. Okay. I wonder where I put it out again. I'm just taking a look at that right now. Shouldn't have put this out. I'm going to save this and run it one more time. Okay, here's the guessing game. I'm going to say 3. That's too low. 50. Too low. 60. 80. Okay, it's really bright on the LED. Okay. Too low. Boy, this is too high. 96. Okay, so it's 96 and then it shut off. All right, so there I programmed it in Matlab. You can do the same thing in Octave. I'll just go ahead and copy this back in, and you can see that it finally finished on this because I probably reset it. Okay, so there's my code right there on the number guessing game. Got to run that in a Matlab or Octave window and from the console, just because it doesn't like this repeated over and over again within the Jupyter Notebook. All right, so that's it on if statements. I hope you enjoyed it. Also, programming these simple games just to be able to use while loops and if statements.